Welcome. I will be starting shortly. Welcome, everybody. This is Microcontrollers with kingernorth, and this is episode 10. This is working with shift registers out with CircuitPython and Arduino. So let's get started. Let's have a look at the boards we're using today. This is our Arduino on the right-hand side, and we have a single shift register there. That is a particular chip, and that is the 74HC 595, and as you can just see, it just froze on the image. I'm having some problems with the camera freezing today, so we're going to see what happens. We're going to try to persevere, and we'll see what happens and see if we can carry on. So we'll continue on with that, and we're on the left hand side. We have our typical Feather M4 Express from Adafruit, and this is running CircuitPython. And in that particular board, we have two shift registers connected there, and they're both talking, and we're using 16 additional LEDs. So let me go to my main page, and I'll probably have to refresh this camera again, and we'll see what happens, and we'll see if this is going to cooperate today or not. It's been giving me a hard time, but I think we can still get through this. So let me just move this one out of the way, and we're going to bring this one in. In fact, we're going to bring it over here like this. And then we're even going to zoom in a bit, and of course it wants to freeze while we're doing that. This is some of the problems we're having today. Technical difficulties. Who knows what Windows is doing in the background? So here it is. This is what we've got. So this is it, and if it freezes, we're just going to let it freeze, and we're just going to carry on. We're going to talk about it anyways. So here it is here. This is our Uno here on the standard Uno, nothing fancy about that. Arduino Uno, people have been using those for ages. And then on the board, connected to it with the wires, we have 4 different lights, and we also have the board. And this might be some of the problem. I just noticed that the focus is trying to go in and out because of the lighting, and that might be causing us some trouble. So I think it just froze again, but let's carry on, and let's have a look at what's involved in this chip before we get into the program here. So here we go here, and we'll just turn that one off for a moment. So what we have here is we have ourselves a nice little chip, and we can zoom that in a little bit more. This is your typical 74HC 595. Now the 74 just means that it's a dip mount, just like I'm using there on the proto board, so I can plug it in. You can also get a surface mount, and I believe the surface mount version is 54 instead of 74. But we have this chip here, and what we have is we have 16 pins on it. Now we have to supply it with power way up here at pin 16. This is on the legend here, so that's our positive power supply. Now this chip is pretty versatile. We're using it here, and it's mostly used with 5-volt systems, but it can be used with anything from 2 volts to 6 volts. So it will work with both CircuitPython and on the microcontrollers that use 3.3, like the CircuitPython M4 Express, or it will also work on the Arduino, which most of those are going to be 5 volt. There are some 3.3 volt, but it will work with either type of board. Down here we have the ground connection. This is pin 8. Pin 8 is nothing more than the common that's connected from your power supply. So that's going to be the red and the black wires that go from the Uno over to the breadboard. The important ones here that we have are going to be the 8 output pins. The 8 output pins are Q1, or Q0 actually, Q0 through Q7. And if we notice, Q0 is way down here on pin 15. So it's beside the power pin. It happens to be there. And then the rest of them are here. So this is the first output pin for the first bit. And that's what it uses, is 8 bits of information. It's a serial connection. And it then goes to Q1, Q2, Q3, Q4, Q5, Q6, and Q7. So those are the 8 pins that we're going to connect the LEDs to. And I'll show you a diagram that helps show you that as well. Then what we have is we have a few other things on here. We have something called OE, which is output enable. And basically, on that case there, is we are going to make sure that we connect it up. And we are going to have it connected. And I'll show you how that's wired, because that's connected on here. And I believe that one is actually connected to a ground connection. So if that's grounded, it enables it. So it's enabled on low is what we're doing there. So it says active low. And then we have a couple of, we have DS, which is the data serial input. That comes up here on pin 14. Then on pins 11 and 12 are the shift registers. That's the clock input. And then we also have what they call they're both clock inputs, but one is for the shift register itself and the other one is for the storage register. So one puts in the data and the other one puts in the pulse telling it where to go in the sequence. So that's what's happening there. And the other one is just a reset, master reset, and we power that high in order to keep it going. So that's our basic chip. So that's what we're using there. So let's just bring that zoom back down and we'll move on to the next image I have here. So the next image here is when we're talking about these numbers, we keep talking about using different individual bits. Well, we end up with some different numbering systems here. And the numbering system we use all the time is this one here on the top left, and it's called decimal. Decimal is what we're used to. That's base 10 numbering system. So that's what we use to do currency here in North America. So everything goes, we have pennies, nickels, dimes, but everything goes in groups of 10 from 0 to 9, and then we start repeating numbers. So we go 0 to 9, and then we go to 10, which is just a 1 and a 0, and then 1, 1, 1, 2, 1, 3, and so on. And that just keeps going on and on and on. In binary, we use a number of bits to represent it. Now, binary is kind of a strange one if you're not used to it. You count from the right to the left, where the least significant variable, in other words, the least significant digit, is on the right-hand side. So when we're 0, binary, it's all zeros. When we're equal to 1, on the right-hand side we have a 1, and the rest are 0. Binary only counts with 2 digits, 0 and 1. So once we've done this, we have to start changing our pattern. So what happens here is this first column in binary is equal to a value of 1. The second column from the right is worth a value of 2. The next one is worth a value of 4. And you can see they keep doubling. So it goes from 0, it goes from 1 to 2 to 4, then to 8, and then to 16. And the next one would be 32, and then 64, and 128. And it would just keep going on how many binary digits you wanted to add. But it's all done with zeros and 1. So for instance, something like 7, we can see here that it becomes 1, and you read it right to left when you're reading binary, 11100. So you'd end up with 111. That would be 1 plus 2 plus 4 equals 7. And that's how you figure out what binary value and decimal values are equivalent. Good morning, Walter. Yeah, quite the light show. Well, we'll see if that goes because my camera's not doing it. So right now the light show's being very quiet. But we'll get that showing just so we can see what's happening. We'll get that going. When we carry on with our binary numbers, one of the important numbers here is 15 in decimal. And 15 is just 1 plus 2 plus 4 plus 8 adds up to 15, and that all becomes 1111. So those are binary numbers. And binary numbers, like I said, are very important that we use that in today's world. Octal, we're going to skip for today. Octal is a base 7, so it goes from 0 to 7, and then it starts counting again. So it goes 0 to 7, 10 to 17, 20 to 27, and so on. The other one we need to concern ourselves with today is going to be hexadecimal. Hexadecimal is used quite a bit by computers. In fact, decimal, binary, and hexadecimal are used a lot by computers. So hexadecimal compared to decimal is the same from 0 to 9. Then it differs, because hexadecimal is only done with a single digit to represent 4 bits, the first 4 bits in Boolean. So from 9, then we have to go to A, B, C, D, E, and then F. And this is important too. So F is 1111, which is decimal 15. So it's a base 16 system. So hexadecimal is base 16, binary is base 2, decimal is base 10. And that's what the different numbering systems are. So it gets a little tricky to get used to that, but that's what happens. So now let me show you how we wire this thing up, because there's a lot going on in here. This is the circuit that's on my Circuit Playground Express board. And we're going to zoom into here because we're going to need to. Because let me tell you, this is very confusing. And I'm hoping that I can, oh, look at that. It'll let me drag down to here. So I'm going to show you half of the circuit. And that's this half right here. If it'll stay, it wants to go there. That's okay though. So here's a single 74HC595 chip. Going off to the right hand side here, what I have is I have a power wire which is connected to my plus 5 volts of our Arduino, plus 3.3 for CircuitPython. I have a blue wire, I have a yellow wire, and I have this green wire. And these 3 wires are the communication wires that are going to connect up to my Uno. And I'll show you where those go, and we'll talk about those a little bit further. And then what we have is we have the blue wire is the serial information coming in. And what there is, there's another pin which looks a lot like Q7, but it's not. It's Q7, and then it's got this little exclamation type mark, this little accent over it. And that is communications out going to the next chip. And that's what we're going to do when we combine more than one of these 74HC595 shift registers together. In fact, we can have up to 8 of them. 8 each have 8 LEDs. That means we could actually run 64 LEDs with only 3 wires connected to our Arduino using up our input-output pins. So it allows us to expand on that greatly. And we can control each individual lamp as we go. All our outputs are just connected through resistors, through the LEDs, and then back to the common, which is the ground connection on your board. Now, these other 2 communication connections, the serial one goes to the first chip, and then passes through the chip to go to the next chip, and then so on if we have additionals. The other 2, which are the data and the clock, they are connected to every chip. So they just bounce from one chip to the next. In fact, when I bring that up, we can see that it's no more than a simple connection. And if we had a third chip, these 2 wires would continue on. That's basically what happens. And the last chip in your set, there's no connection for serial out, which is that Q7 with the exclamation, with the little tick mark, and that's because that's the end of the talking. So this is how we're going to electrically connect it. And we're going to have a look and see how that affects it for our program. So let's go ahead and have a look at that program now. So we'll turn back on our Arduino program, we'll turn this off, and I'm going to refresh this screen because I want to be able to talk to it and show you what's happening in here. I have a simple little program running in here, so we'll just let that update. So we've got that going on here, and it may be my focus bouncing around, I'm not sure. If I move that over a little bit and I keep my focus, will it maintain? I don't know. It's working the camera pretty hard because of the bright lights, and they are bright. If I shadow those out, does it make a difference? Yeah, it tends to want to stay on the board, but I'm not going to hold my hands there for too long. Ah, look at that. As soon as I move my hand, it decided to freeze. So I don't know whether I'm going to be able to do anything with this or not today. But let's look what's going on in our program. So we'll refresh that one more time. We're going to give it a shot. We're going to see if it holds up. If it doesn't, oh well, we're going to have to just go through this part of it. So this is our program up here. So what I have is I have this part of the program. So I've created a new program in Arduino, and I've just put my comments at the top. This is my comments here, and it says original code is from Arduino. And I modified this code because I found their code very confusing when I read it. I had to go through it. I understand how these 595s work, this shift register chip, so I'm going to explain it to you a little bit better here. So what's happening in here is we don't need any helper files with Arduino, so there's none required whatsoever. So this is nice, and all we're going to do is we're going to send a simple pattern to those lights, and that's all we were doing, is we're just turning on the lights in sequence, starting with the one that's wired to Q0, and then to Q1, to Q2, to Q3, 4, 5, 6, and 7. So what we do is we have to create some variables in this thing here. We have to create the latch, there's the clock, and then there's the data pin. Okay, so those are the 3 different connections that are needed, and these all connect to the different pins on here. The data pin is your serial port. That's your DS connection. That's connected to pin 14 on your on the IC chip, and it's connected to pin, in my case I connected it to pin 2 on my Uno board. And the other 2 here are what I call the latch pin and the clock pin. One is setting the pulse, and the other one is sending whether the latch is either going to be an answer of 0 or 1. That's the binary value to set to that particular output at given time. So the information coming in about the latching is going to happen on pin 4, and the clock is going to happen on pin 5. The clock is just that steady pulse. So as it sees each rise of the clock, it says, okay, what's my latch pin? Write that into the buffer on the chip, and we'll go through that in the program. And then I've created a couple things here, something called data and something called data array. I just want to create my own custom pattern for the lights. I have a couple of counters that are working in here, so I've just created a couple of variables for those. And then what I've got is I've got the pin state, and it's based on the bit value. So this is just another variable that I'm going to be working with. When I get into my setup, it's pretty straightforward. In my setup, there's very little in here. It's a very short portion for the first part. I'm going to set my pin modes, and their outputs, you don't really have to set those in the Arduino. I like to set all my pins properly for inputs or outputs, regardless of whether I need to or not. It just reminds me that I'm using them. So I've got 3 pin modes here for the latch pin, the clock pin, and the data pin, and they're all as outputs on the Arduino board. I don't like to forget that they're there. Next thing is I've got my serial begin, and that's just to open up my serial monitor so that we can see what's happening inside the program. I'm going to use a couple of print statements, and I've got one here that says getting ready. So just a message to let me know that it's talking to the serial monitor when it's running. The next thing I talked about was this data array. Now, this is where we're seeing different types of numbers. So let me explain what's going on here. So in an array, we have a bunch of variables that are going to be the same, and they take up various positions in the array, starting from position 0 in the array, position 1, position 2, all the way up to position 8. So there's actually 9 variables that I'm recording here. And what happens in here is that in position 0, what I want it to do, this is a hex value. So this is 0x00. So 0, if we remember what was on the number sheet, 0x just means that this is a hexadecimal number type. That's how we can tell that this is going to be a hex number. And my hex number happens to be 00. 00, this is what it is in binary. So 0b would be the binary equivalent, and it's just 8 zeros. Starting from the right, this is my least significant bit on the right, to my most significant digit on the left. It's just 0, 0, 0, 0, 0, 0, 0, 0. The next array, the next spot in my array, I want to turn on the first light in position Q0. So that's the one that's wired to Q0. So I have to change my array now to hexadecimal 01, which in binary is 1, 0, 0, 0, 0, 0, 0, 0. So it starts from the right and goes back to the left. And then the next one would be, I want to turn on 2 of the lights. Well, that's 1 plus 2 equals 3. So there's my hexadecimal 3. So it's hexadecimal 03, which is 1, 1, 0, 0, 0, 0, 0, 0. I next want to turn on 4 of the lights, or 3 of the lights in a row. So now it becomes 1 plus 2 plus 4. That's a 7. I want to turn on 4 of the lights. 1 plus 2 plus 4 plus 8. That's F in hexadecimal. So that's how I'm building this. Then I want to go to 5 ones in a row. Well, the first 4 is an F. Then I start counting again for the second digit of hexadecimal. So I start again with just a 1 0 0 0, which is a 1. Then a 3, a 7, and an F. So the pattern should be visible here as I'm doing this. I start with 0 0, 1 0, 3 0, 7 0, F0, F1, F3, F7, FF. So I'm actually in hexadecimal. I'm just filling in the numbers. So I'm actually going from a no lights on, no LEDs, to 1, to 2, to 3, to 4, to 5, to 6, to 7, to all 8. That's what I've done. The next thing I do is I build the array. Now I build it inside the main loop. This is a little different than what we're probably used to. Normally we build our arrays outside. In here I build it inside so that I can actually step through it as I'm building it. And what I'm going to do is I'm just going to build this array. And then what I want to do is I want to move down here. Now this is where everything starts to happen. It says I got to write the digital clock to low. What that does, it sets it low to disable any updates that I'm sending out right now. And then I write my data pin to 0, which helps clear the buffer, which says, okay, I'm clear. I'm ready to start accepting new data. So then what I do is I come in here and I say, okay, great. Let's take it and let's write our clock pin to 0 to pause the clock. Then I want to print on my sheet, and you'll see that in a moment. I want to print what I is equal to. So this is my counter. And we're just going to serial print I is equal to whatever. And then I'm going to say if the data, and this is Y, and this is exponent I, so this is I times 1. And then what we're going to do is we're just going to say turn on the pin state. We're going to go through this. We're going to walk through this. It's a little bit clearer probably when I get to my CircuitPython version. But in this one here, I'm just writing down, is the pin state a 1 or a 0, and I'm putting that onto my serial monitor so I can understand what's happening there. Then what I do is I have to set the data pin to whatever pin state that is. Is it going to be a 1 or a 0? And if it's a 1, then I do my clock pin to 1, and I turn my data bit on for the next bit. So I just keep resetting the data bit. So I just turn it on, write the position, and then put it out. So I save the values in there. And this keeps repeating for all 8 bits. When it's finished doing that, it comes down here, and it comes down to the next spot. It prints a blank line. And then what I got is I pause the clock. I set the latch pin to high. And what that does, it pushes the information from the buffer where I copied it into, my 8 bits, and writes it out to all 8 LEDs at one time. So that's the purpose of that. It gets a little tricky, but that's what it does. And then finally, what I have here is I have a small delay so that I can see the lights so they don't flash by in a hurry. So let's turn that back on and let's see how that works. I'm going to refresh my camera. And we can see here that the lights are coming on. That's Q0, Q1, Q2, and Q3, and then it continues on up. So we're actually counting through them until we paused again. And then we can look at the data. So this is the data that's happening on here. In fact, I'll refresh the camera once more so you can see the two of them if they're going to react together. Oh, it looks like my Arduino window paused. So what I'm going to do is I'm going to go ahead and I'm going to upload this to here. Let's make sure I'm still connected. Oh, good. It's going to be one of those days, is it? Okay, let me get my serial monitor information over there for you so I can show you. So here we are. This is what's happening in the pin states. So as we're going through this scrolling, we can refresh this data. And I will pause it here. And we can see at this point here, when I paused it, that I7 was equal to 0. 1, and then starting from here, from bit 0, we had 1, 2, 3, 4, 5, 6, 7 of the LEDs on, 1 off. If I roll down to the next one, I see all 8 are on. I scroll down to the next one, I see all of them are off. Scroll down to the next one, only I0, in other words, Q0 is on. Bits of data all being pushed out at the same time. So this is how I'm going through, and through each one of these blocks, I just keep adding a single point, and that's based off my array up above. And as I get to the end, we can see that we end up all the way up here to completed with all 8 running again. So unfortunately, the camera is being less than cooperative today, but we can see that all of this information going. I'll put that back onto auto scroll, and we'll see that that just streams by. That's how fast we're updating. If we wanted it to go slower, I can come in here to my program. I'm going to change my delay from 500 to 1000. I'm going to go ahead and upload that file. And it says compiling the sketch right now, and then hopefully it's going to say that it's uploading, and it is. It's done uploading. Let's look at here, and I'll turn off my auto scroll. Let me show you the start of the program. Remember I said I get that message getting ready? Well, there it was. And my first values were all zeros, and then 1 dot, 1 LED, and so on. So this is going through. This is a little slower. You might even get a chance to see the numbers go by this way. So what I've done is I've slowed down the pulse rate just to show you that that is happening. We'll try refreshing the camera one more time. And we should see the lights blinking slower than what they were before. They're at a much slower pace. Maybe that'll help the camera too. I don't know whether it's all those extra LEDs. I could see this thing trying to refocus all the time. No, it's just not happy today. What can I tell you? So that's how it works with Arduino. So now we'll go through a bigger explanation, and we'll get through that with CircuitPython. But it's actually quite interesting because you can actually send particular values out to it if you want to. And I'm going to show you that when we get into CircuitPython. We'll see if it cooperates any better. And we're going to jump out of this one here for a moment. So let me just turn off that particular data patch. We'll turn on the camera for the mute, and let me change out my items here. We'll see how much this really gets upset now. I'm going to go ahead and swap that out, and we'll see if we can make this work with the CircuitPython. So I'll refresh my camera once more. We'll see where we are on the camera. Oh, look at that. Now I can see it. Okay, so what I've got here, I'm able to see all of my devices now. I don't know whether this will work any better with this one or not. Oh, I banged one of my, banging a couple of my LEDs. I'll just straighten them out a little bit. So what I've got going on here, as I'm moving it, I've got my first chip is this one on the left. That's the first one. So the blue wire from the board connects to this data in. This is my serial input. And then my serial out is the other blue wire that jumps out of here and jumps over to this board. It just jumps in behind the little white wires there, in mixed with the white wire and the orange wire, but they're there. And did this freeze? Oh yeah, it froze. So it's just something to do with the camera. I think something's happening with the computer in the background today. It must be doing some sort of update that it's not letting me know about. I tried searching for something, I didn't see anything there. But we will persevere. So what I have here is I have my first set of data going here. Up in the top right-hand corner of the red ones is position Q0. Then when I move to the left, it becomes Q1, Q2, Q3. Then I move to the row at the bottom, starting on the right, and that is Q5, 6, actually 4, 5, 6, and 7. Then if you look at the green LEDs on the right-hand side, they follow the same pattern. So the top right LED in there is Q0. So that'll be the first one that lights up when you look at that pattern. Let's see if it'll run for a few seconds here. You can see we're moving through the Qs, and there we are onto the greens, and they're moving across, and we have all the lights come on at the end, and then they all shut off. And that's the way I have the program set up here. So let's have a look at what's inside of our program here. So this is our program on the right-hand side of the page here, and this is just a shift register test. Now I wrote this one had to find the information, and I found it out there that I needed to build this. So what I have on here is I have my helper files, typical things that we have in Python is because it doesn't load in anything that we don't need. It's already in memory on the chip. The chip has very large memory storage, has at least a couple of megs of storage, but we don't load them all into the processor unless we need them. And so we have time because we're going to create delays, board because we have to designate some pinouts, digital I/O because we're going to set those pins as outputs. Simple I/O is the internal bit that allows the shift register to work. It's an internal bit just like it was already built into Arduino. So that way we don't actually have any other things come in. These are all default values within the board, so you don't actually put anything into the library file this time. The setup is very short. When we're talking CircuitPython, all I have to do is take my 3 outputs and set them up. So I took my latch and I created it and I designated it to pin 6. And then I said, hey, my latch direction is going to be output. And you have to do it in 2 steps when you're dealing with CircuitPython. Is first of all, you designate your pins, and then you designate them as inputs or outputs. And I've designated these as outputs. And over here, I just created my own little note to remind me that this board connection D6 is going to connect to IC pin 12. So that's just my easy way to remember so that I don't forget later on when I'm working with this. And that's all the variables I need because everything else gets created automatically within the program. And we're going to look at the rest of the program here, and it's the while true. This is their loop. So it's actually a very short program in CircuitPython. It's shorter than what it was in Arduino. So what I'm doing here is I'm setting in the default of a value of 0 to clear all the LEDs. So I'm writing in a value of LEDs is equal to 0x. Remember, if I put in a 0 and then a small x, that means it's a hexadecimal number. And I've created it as FFFF. The reason I've done this is what I've done, and actually I'm not putting in a value of 0 to clear them all. I'm actually putting a value of 1 in everything. What this does is write a whole bunch, 16 ones into a buffer. And that's what it is. It's 16 ones in binary. So I can bring here LEDs equal to 0. I started out with that because when I was playing with this initially, I had zeros in here. And I decided, well, maybe I'll make all the lights flash at once instead. So we're going to show you how I can change that around, though. Hopefully I can get the program working long enough and the camera working long enough to show you. Then we have here, I have enable writing to the buffer on the chips. And all I do is I take my latch value and make it false. And then it says write the second value. You notice we actually write, because in this one here, and this is just something that's involved with this particular type of a file, is what we have here is we actually look at the most significant bit first. And it's set to true. It is set to true by default. I can actually remove that and it still works fine, but I wanted to leave it in here to remind myself. I'm actually looking at going from the left-hand binary digit to the right-hand. So what this does, this is bit shift. So what this simply says is, simple I/O was part of the interior, and it says do the shift output, use the data, use the clock, so these are my variables, my LEDs that I've written here, FFFFF, bit shift them to the right by 8 bits, and then write it. And when it does, it actually writes to the second chip first, because I'm going from the highest value to the lowest value, and the highest values are in the second chip. Then I do the same statement again, and I rewrite, and I just write this time LEDs without the bit shifting, without moving my bits over by 8, and just saying fill in the first 8 on the first chip. And then what I do is down here is I take it and I say latch is true, which says go ahead and send that information from the buffer out to the LEDs. And then I'm going to pause for 2 seconds. Remember, this is not milliseconds like the Arduino. This is actually done in seconds, so this is 2 seconds. So that's what happens. So let's reset the clock, reset the image on the camera, and what we should see is we should see all of these lights, and they're on right off the bat. Now we're going to go through the 16 pulses, We'll see if it survives long enough without freezing, and it didn't. Oh, there it goes, and they're all on. Hey, we actually made it through a cycle. There was still a hiccup in there in our visual, but not in the program. And we can see that they're actually going, and instead of going all to zeros, they're doing that. Now, if I want to see this information that's happening, I can open up my serial monitor, and I can see it. LEDs is equal to 0. That's my 2-second delay. That's when all the LEDs should be on. So right now, the LEDs should be on. And our camera paused, so of course we can't time it. But that's what's happening in there. So what I'm doing is I'm printing out my hexadecimal value. And what we can see here is when we're writing these values, because it doesn't like leading zeros, I write them backwards, because otherwise it doesn't know how to write 0001 when I started. So I'm actually writing the values backwards. I'm filling them in from the end and going the other way. It's just unfortunately the way that it likes to talk, so it makes it a little bit harder to understand. If I want to show you what happens here, what we're going to do is we're going to get this ready. I'm going to take this and I'm going to say this time I want every other LED on. If I think about it with the 8 bits, starting from the right, if I want Q0 to be on, Q1 to be off, Q2 to be on, Q3 to be off. That would be a 1 plus a 4 is a 5. So let me go in here and put in 5555. So that should be every other LED should come on when I do this. So first thing I'm going to do is reset the camera, because we're hopefully going to see this. I'll refresh it and then I'll save this. And when I save this, it'll reboot. Every other LED is on to start. Look at that. And the camera froze. But we did get to see every other LED come on. So I can actually manipulate this number to figure out which ones of the LEDs I want on. So this is unfortunately the camera, but we can see we can manipulate this and make it anything we want. So now that we have that going, let's have a look at how we do our loop. So this is how I do my loop in here. And I'm going to explain a couple things because it's going to make more sense. So what I'm saying this time is for I in range of 16. So in other words, it's going to count from 0 to 15. Because it says as long as the range is less than 16, but it always starts at 0. So it's going to go 0 and go through this once. I is going to equal 0. We're going to go through this once. And then it's going to go through to 1, and then to 2, and then so on and so forth. So what happens here, when we go through this, we can actually get in here and we can do the multiplication. So this is how I figure out which bit to turn on as I walk through one at a time. And what I do here is I use my hexadecimal number of 2, and I multiply it by I. And as we do that, we will find out that we will go through everything. And in fact, actually, if you take anything and multiply it by an exponent of 1, I believe it comes out to 1 by math. And then it just, actually, it'd be 0 would be the first one, so it actually goes out to pin 1. Then when you do it to an exponent of 1, 2 to the exponent of 1 is a 2. The 2 to the exponent of 2 is 2 squared, which is 4. 2 to the exponent of 3, which is 2 cubed, is 8. So we actually walk up through those numbers. So we actually use the value that's underneath each of the binary bits. I know it's a little confusing, but it works. Next thing we do is we take the buffer and we turn it off. We go in here and it says write to the second shift register chip, so the 74HC595. So we push all that information out, just like we did up here. Then we push out the first chips, all the data for that based on whatever that value is for LED bit. Then we turn it on, which pushes all the information out of the buffer and back into the actual chips, to the output pins of the chips. So that's where you see the LED lights come on. And then we look at it, and finally I print the hex value of LED bit. And then I pause for a half a second. So what we see here when I look at the bottom here, these are the hexadecimal values I'm reading out. And we should see these come out as 1248, 1248, but each time we add another 0 to the right-hand side of it. So if you think about this in hexadecimal, that's actually 0008, which is going to be the 15th bit, counting from Boolean. because 80000 becomes, in Boolean, would be equal to 0000000000001. So it's actually quite a ways up there, and I may have missed a zero in there. But the whole idea is this number goes out here. So when it goes through the first time, there, when it says it's bit 1 turns on, which is Q0 of the first chip. And then bit 2 is Q1 of the first chip. And it just keeps moving on through the positions. So that's how we end up with 16 LEDs coming on. And as we walk through them here, for the moment that it decides to work, there's our every other bit, and then it starts over with the first set again and continues on. So that's basically what it does. So unfortunately, my camera's not been working well today. I wished it did, but it's not. So I don't know how long it'll run for. Who knows? Maybe it's settled down. Who knows? Windows could be updating in the background. It has a tendency to do that. But anyways, we're here. This is working for the moment. Actually, I think this is one of the longest I've seen the camera run without pausing today. So not sure why that's happening, but that's what's happening inside the chip. So I hope that explanation is a little bit easier to understand. You can definitely go back through it. There's no problem with doing that. I would definitely suggest doing that if you need to. Don't forget, you can look all this information up. I can show you very quickly where some of this stuff is found. So what I'm going to do here is I'm going to open up my browser window and I will link it. And we'll show you where to find some of this stuff. So what I'm going to do here is I'm going to add a source. In fact, actually, let me just move over to my big camera page. Look at this. And it's frozen in there, but that's okay. But we're going to add a source. We're going to add a screen. And there's my Chrome window. We'll just make that a bit bigger so you can see what's going on. And we're going to look up a couple of things here. So one of the things I can do is when you're looking for this stuff, you're starting out with Arduino. Let's go to Arduino. And it's Arduino.cc is the main site. So when we're in here and we're looking at the Arduino site for finding information, we can look here for reference, or you could go into tutorials. And what you can look under tutorials is, I'm going to go up here and I'm going to look up shift register. I've looked this up before. And we just give it down here. And it's not giving me a lot. So what I'm going to do is I'm going to use the command. Actually, what I'll do is I'll show you, if we don't know where to find things, we can go in here to reference. In reference, these are all the built-in instructions that are inside of Arduino. So this is inside your main program, or all these things. And this is considered advanced inputs and outputs. There's something here that we use called shift out. This is how we talk to it. So if we click on shift out, Arduino gives you a page of information here. And on this page, they give you the syntax, and they talk about shift out, data pin, clock pin, bit order, which is either least significant bit first or most significant bit first, and then the actual value that we're writing to it. And it explains that down here. And then there's a little bit of code here to help you walk through some basic stuff. So if you want to try this, you can definitely hook all this up and give it a shot. It tells you here which pin is connected. The latch pin is connected to pin 8. Clock pin is pin 12. Data pin's on pin 11. You may or may not remember where all that stuff is, but this will get you started. You, of course, can also go into Google. And if you decided to search on Google, you can go to a shift register Arduino. If I go here, I get a whole bunch of stuff here. Here's another big tutorial on shift out. Let's see if that brings us, this is a different page. This is a detailed page from the Arduino site that says serial to parallel shifting out with a 74HC595. So if you forget the chip, here it is. And what they do is they talk about it. Here's a picture of the chip. So if you need to know what the pinouts are and what they're called, they're all here. And then what they do is they give you an example. So they give you an example here. You just want to be able to turn it on. And what they do is they do some basic connections here. And then they show you how to wire it up. And they're going to add 8 LEDs to it. And they're going to add the resistors to it. And then we end up with that circuit. So here's the circuit here. And then you go into the code. Now the code, they have 3 different codes. That's a code you can use all with that same picture. You don't need a second picture to do it. And over here they give you a timing diagram to show you how things are done. And there's also a logic table of what's going on in here. It gets confusing. It takes a little while to get used to. But don't worry about that. The whole idea is to experiment. So you can do something called Hello World 1 by 1 and using an array. So it actually goes there. Using an array is what I based my program on that's in the Arduino that you saw earlier. Okay. The next thing is we're going to add a second shift register. So they talk about that here and they show you the big diagram here and how it's wired up. So now you have 2 of them. And then they show you that circuit diagram that I showed you earlier. So it's all right here. And then they talk about the code. And here they have, again, 3 examples built into it. You just click on each one if you want to see it. And if you want to go to byte by byte, here's the shift of the code. And you can follow through. You can see the code's pretty long. That's because they have a lot of comments in here. And some of these comments are going to make more sense than others. If you do it, just copy the code, dump it in, and then try working through each part and then manipulating it one piece at a time to figure out what you've changed and what you haven't changed. So this is what goes on here. And that's what the first part is. If you feel a little bit more confident, you can go out here to images and you can start seeing some pictures that people have done of how they wired theirs up. So I can click on that. It gives me a more detailed image up here. And I can look through that 74HC. And again, there are lots of images here. There's the Arduino shift out picture. Here's another one. Somebody's done it with neater lines. You'll see different methods of people wiring it. This one that looks like a spaghetti, kind of like it does when you really hook it up. So what you need to do is you need to go through it. And here's somebody who's just showing a chip without a board, a little bit bigger so it's more readable. And you just carry on from there. You can actually try many, many different ways of doing this. So that would be the first thing that I would do is look at something like this. If you want to go into CircuitPython now and learn how to do this, we're going to look for something a little different. We're going to start out with a place called Read the Docs. And it's going to be CircuitPython. And if I go into there, I want all. So I want to go in here to readthedocs.org is a good organization. And the projects are all different topics. And CircuitPython is the one we want to get into here. And when we go into here, we end up with a page that looks like this. I'm going to go to the latest version. And this tells me all about CircuitPython. So this is where I find details, kind of like the Arduino page where you found out information about Arduino. This is where I find out information about here. And then what they do is they break this down into a number of items too. And core modules. These are all the things that are the basic modules within there. Each one of these represents an item in the module, and then these are the things that are adjustable within the module. So just to give you a quick example of one that we've been using quite a bit, let's go look at time, because you can see there's quite a few modules. And it's just laid out different than the Arduino one. But here's time. If I click on time, it now gives me a detailed information about what happens in time. So time module here, there's one called monotonic. We used that when we created timers. We were using monotonic. And monotonic basically just got in what was the current time of the clock, and it tells me that it's going to be a floating number type. Here's sleep. This is the one we use all the time. Sleep for a given number of seconds. Parameters in seconds with a float, because we have to be able to include decimals. Otherwise, we'd never get under 1 second of delay. So this is, we can go into fractions of a second. And then there's a bunch more. There's something here called structure time. Then you can go in here, time monic nanoseconds if milliseconds aren't fast enough for you. You have local time, make time. Those are all things that are there for you. So you can see that was actually all available to you. And one of the ones that we use today is, I'm going to go backwards here, and I'm going to look up something called Simple IO. And I'm going to go ahead and search. It's going to take a moment to search in Google. When you pull this up, Simple IO, beginner friendly, Simple IO from the project. Okay, so let's just try that one. And here it is, source code for Simple IO. That's the source code for it. Here's examples. Oh, so here we go. Tone is using Simple. This is just all the things that use Simple when we have Simple IO. And shift in, here's the one we used, shift out. Shift out, data pin, clock value, most significant true, and the bit count. We can also include the bit count. So all of this information is here, and these are little examples of what we can do with it. And it says while true, and then how we build these statements. So it looks a little complicated. The reality is the more you use this, the more it'll make sense. So when you're learning how to do a new program, you need to know where to get the reference materials. So I hope that helps a little bit. That gives me the where to find some of this stuff. I'm going to turn that out. We're going to see if we can't get that light show going for another moment, just so we can do this as the log out, because I hope this has been informative. I know it's interesting. I wish my camera was working better today. I'll have to see what's going on my computer, why it's not happy this week. But we have some lights going. We're a little under that hour, but I think that's okay. So this was shift register out using that 74HC595 chip. That is a shift register chip that allows us to do a lot, whether it's on Arduino or whether it's on CircuitPython. It does work with either voltage just fine. We just have to run it and see what we can do with it. So that's everything for this week. Don't forget, this was the code. It's still running in the background even though the image isn't updating. This is still running. So I hope you've enjoyed it. I'll work on my camera issues for next week. And I think with what we're doing here, I think we're going to be in time. We're going to probably talk about subroutines next week and how we use subroutines within these two languages. I talked about timers because they were an important topic. Subroutines also are, because it's where you can do things multiple times but only write the code once and then just access it over and over and over again. So until next time, till next week, I hope this has been interesting for you. Sorry the camera didn't work as well as we would have liked this week, so you had to listen to me more than watch the pretty lights flash. But that's the way it goes. Remember, this is Microcontrollers with kingernorth. This was episode 10. And, well, thank you, Walter. It says you learned a lot, and I hope you did. And I'm just trying to get it through. But the whole key with any of this stuff is to play with it. So this was shift register out using CircuitPython and Arduino. Try it. Play with it. It never hurts. Remember, you can follow me on Twitter at kingernorth. Or you can subscribe to me and give me a thumbs up on YouTube at youtube.com/kingernorth. I appreciate that. That way you'll get notices of when these things are coming up. I try to put it out the day ahead of time to say when I'm going to do my next stream. My next stream is planned for next Saturday. And for the live stream, this will be available on the site actually very shortly. And thanks for coming by. And we'll see you next time with a new topic. Take care, everyone.